So we are modeling quadratics using real-life situations and seeing how quadratics applies to it, okay? And to be honest, it's more of, let's take a look at some examples, and then you'll start to notice patterns and trends on when you'll find the vertex, or when you'll find the x-intercepts, or when you'll find the maximum value or the minimum value, et cetera, et cetera. So the first one, a farmer wishes to fence off a maximum area possible to make a rectangular field. She has 100 meters of fencing. One side of the land borders a canal. Find the maximum area of the field. So when you're looking at this particular situation, you have to ask yourself, what are you trying to find? Maximum area. And this area you're trying to find is the area for a shape of a what? A rectangle. So what is the equation for the area of a rectangle? Length times width. Okay? Now the thing is that you basically need an equation that you're going to have to deal with. Now length times width, there's a downside to this, is that we're looking at 3 variables versus 2. Okay? Which means that we're going to need to rewrite one of these variables in terms of the other, so then that way we can actually solve this out. So there's another piece of information that's very critical in helping us figure out that piece. What additional information do we have here?
The border canal.
It definitely borders the canal. What else? Say again?
150 meters of fence.
There's 150 meters of fencing. Everybody knows what a fence does, correct?
Yeah.
It traps in whatever. So this fencing is going to go around this part, this part, this part is going to go across the canal? No, it's not. So fencing represents what mathematical idea? Perimeter. What's the perimeter of a rectangle? All the 4 sides add together. So in this case, it's going to be, well, we're not adding all 4 sides, we're only adding
2W plus L.
It's going to be 2W plus L. Is everybody still with me? Okay. That equation for perimeter is going to help us figure out one of the variables in terms of the other so that we can plug it into our area equation. Yes?
Why do you only add the 2 to W?
Because the canal is on the other side of the length, and so we're actually going to fence the canal. Exactly. Now we know that we have 150 meters of fencing, so that represents my perimeter. And now I have an equation that we can solve for one of our variables, so we can plug in. Which variable do you want to solve for? L will probably be the easiest one, so we won't have to worry about a fraction. How do I solve for L? Say again. I'm trying to solve for L. I'm trying to get L by itself.
Subtract
No,
150.
we're not using subtract 2W, we're just
Subtract
2W.
Subtract 2W to the other side.
Yeah, she thought we were doing elimination, that's why she was trying to.
Oh, no. This is like a linear process. So like it's one equation. Oh yeah. So there it is. Okay, you have length in terms of width, which means that we can take this 150 minus 2W and plug it in here. Is everybody still with me?
Yeah.
So now we'll have an equation to find our maximum area that is in 2 variables and not 3. Let's simplify that. What can I do to make that a little nicer? Distribute. So I'm going to distribute the W to both. And my area equation is 150W minus 2W squared. Now that we have our equation for area and we have just the 2 variables, W is my independent variable and A is my dependent, so my X and my Y. What concept of quadratics are we going to use to find the maximum area? What concept of quadratics represents represents the maximum area. Or better yet, look at the equation. It's a quadratic, yes? Which way does this quadratic open? Up or down? It opens down because it's a negative a with that equation. So I'm just gonna make a quick little graph there. If I'm trying to find the maximum area, the crest also known as the what?
Vertex.
The vertex. The maximum area is the highest area possible that we could potentially have to fence in this farm. Okay? So when you're trying to find the maximum area or the minimum area or the maximum cost or the minimum cost or the maximum height or minimum time, are you with me? What are we looking for? The vertex, and more specifically, what part of the vertex? The y value. Because the x value, in this case the w, tells you what the width would need to be in order to get the maximum area.
That's the range, right?
And it would affect the range as well. So maximum area, we're looking for the y coordinate of the vertex. How do we find the y coordinate of the vertex? What do I need to find first? Gotta find the x. How do I find the x? Negative b over 2a. What's b in this problem? 150. So I have a negative 150 all over 2 times a. What's a? Negative 2. So then I'll have negative 150 over negative 4, and that is 75?
No, 37.5.
37.5?
Yeah, I added 2.
Okay. So 37.5 basically represents the width that the farmer would need to fence in order to get the maximum area. So to find the actual maximum area, to find the y coordinate of the vertex, we need to take that 37.5 and
Plug it in.
into what?
The quadratic.
That represents
Well,
Maximum.
that represents the area.
Yeah.
That represents the area. So we're going to do 150 times 37.5 minus 2 times 37.5 squared. Type that into your calculator. Get your answer. So we type it in and we get what?
2012.
And 12.5.
Meters squared.
And we want to include our units, which are meters squared. That is the maximum area of the field. Okay? If it asks us to find the dimensions that would maximize the area, well, we have our width already. That's what 37.5 represented. We would plug it in to find the length. Plug into this equation up here. It didn't ask for that, but I was just, going to the next step for it. Right. So questions on this? Let's look at the next one. It says a rock that follows a parabolic trajectory. Parabolic means a what? A parabola. After t seconds, the vertical height of the rocket above the ground in meters is given by h of t equals 37t minus t squared. Equation's already given to us. That's always nice. We don't have to find anything. Now it says find the height of the rocket above the ground after 10 seconds. Plug in what? Plug in 10 for what variable? T. Because t is our time. So I'm trying to figure out the height after 10 seconds. So that's 37 times 10 minus 10 squared. 270? 270 meters? Questions on that? Too bad, right? Oh. Find the maximum height above the ground. What is that? How high the rocket bucket is, so that is the vertex. More specifically, it is the y coordinate of the vertex. So can you guys find the y coordinate of the vertex?
Yes.
Okay. Alright. So what'd you guys get the maximum height to be above the ground?
342.25 meters.
42.25 meters. Did I hear that right? Okay. So remember, you find the x coordinate by doing negative b over 2a. B is what number? And a is
No, it's 1.
negative 1. Because it's based off of this original equation. That original equation. So then it's going to be 37 over 2, which is positive 8.
Oh, 8.
So then you take that and then you plug it into the original equation to find your maximum height.
Oh.
Because remember, it's negative b. B is a positive 37, so then when you plug it in, it'd be a negative 37.
Oh,
And a was a negative 1. And so the negative and the negative are positive. So then you type that in, that should give you 342.25 meters. Now it asks you for the length of time the ball is in the air. Okay, the length of time the ball is in the air. So if you think about it real quick, the rocket starts off, it shoots up, and at some point in time it's going to have to do what? Come back down and hit the ground. Okay, so it's asking for the length of time. So you need to figure out what time it started at, and then it ended, and then subtract those two. So basically you're finding the what in this case? The x-intercepts, okay? Now, haven't used too much of our calculator like the graphing feature. So basically we're looking for when the height is at 0. Of course we can use what to solve for t? Quadratic formula, factoring. We can also use our calculator here by plugging this into y1, this equation into y2, and doing what? Graphing and then finding the intersection, okay? We can also do, algebraically, but let's use our calculator too. Yeah, because that's basically what you're doing. You're just having them equal to each other. So 0 here, and then 37x minus x squared. We might have to open up our window some, because what's the highest that it goes? It was like 340, right? So I gotta open up my window some so I can see it. My y max, I'm gonna put it like 345 so I can see it at the top. And then I definitely think it's gonna take more than 3 seconds. What's a good x max?
30.
30, 15. Let's do 30. So when we graph it, there's the y equals 0. There's our quadratic. There's the top, and it looks like it's going to take a little bit longer than 30 seconds for sure. So let's change our window some more to what? 50. There's y equals 0. Here comes the quadratic, and it is good. So let's figure out. This one is very much 0, 0. Let's figure out what that intersection point is right there.
Yeah, that makes sense.
So I know that I have 30 seconds, it's back on the ground, and it starts at 0 seconds. So I have 0 and 37. So what's the length of time? 37 seconds. Questions on this one? Alright, so a company's weekly profit in royals is modeled by the function. It's hard to give it to you. Where U is the number of units sold per week. So U represents the units, P represents your profit, independent, dependent. Find the maximum weekly profit. You have to find the what?
Vertex.
Which part?
X, Y. You have to find X first.
You find X to find Y.
Yes.
Exactly.
The highest.
18.75.
So then you plug that into your equation. And what do you get? This is money we're talking about.
13,525.
So 13,
531.25.
22 what?
25.
Okay, so that's your maximum profit right there. 13,000 and the rest. Now it says the loss for a week's holiday period where no units are sold. If no units are sold, that means U equals what?
0.
0. So if you plug in 0, then our profit, which is technically a loss, is negative 3,000. So we basically lose 3,000 royalties. Yeah? Now it says the number of units sold each week at break-even point for the company. If you break it even, then what?
You're making no money.
You're making no money, so profit has to equal 0. So you plug 0 in, that's what it means to break even. That's the real one for you. So then we plug 0 into y1, all of this into y2, because I strongly suggest not trying to use quadratic formula for this. And then see where they intersect. So I'm going to do that. Got the 0 already there. Negative 0.032x squared. What's the rest?
146x. Minus 3,000.
Leave that random square right there. The equation looks right, yes?
Yep.
Okay. I'm probably going to need to open up my window a little bit. I know my maximum profit was in the 13,000, so I'm going to change my Y max to be about 13,600 to include that. And let's see what we get when we graph this. There's the Y equals 0.
I can calculate. So I just
Yeah, that's the thing. You won't, yeah.
if I have it, you find it.
It just says error. Yeah, it just keeps saying error.
All right. Yes,
I had
okay.
to move my window to
Figure it out. It just has a really big window.
Has a really big window.
yeah, it's like 15,000.
It's like it was huge.
The X max.
The X max is big too.
Oh, jeez. Let's try it. If I can't get it, then I'm going to definitely
That was
go quadratic.
yeah.
Oh, there it is.
The X didn't need to be big. The Y did.
Well, that's the thing. I have a lot base, but
Yeah.
all right.
It'll work.
Get here and there. Let's find that intersection point. Okay, that one right there. Second trace 5. As long as it's in the window, the graph can find it. I'm just going to move my cursor closer. Right on closer. So I'm looking at probably about 1,000 units. Now, real quick, what does that mean?
Oh, exponent.
This represents an exponent, but with scientific notation. This is negative 1 times 10 to the negative 9, so that's 0.000000000.
So it's basically 0.
Okay, so 9 zeros and then a 1. So I'm looking at about.
I did the quadratic formula and I got exactly 1,500.
You got exactly. You don't get this either.
On the screen, I got it. I didn't get it.
And I did type my equation incorrectly.
Like, didn't it have to do with like how big the window is? That it's not exactly exactly.
That is a possibility. Yes. Yes.
I did it and I got 68.5.
If it intersects the
crazy.
x-axis,
That's where
you know
it's
what
actually
it's
So much more.
You know what I'm going to use? So each week at the break-even point. Well, of course, it's always going to intersect twice. But what was the first intersection point?
68
Okay, so you basically have to sell 68 units, about 68 units, in order to even start making money. And so then after, so here, 68 and whatever. Then at whatever this value was, after that you're gonna start losing money. So the number of units sold to break even is going to be the difference between this value and whatever this value is. So we are going to need to figure out what that is. All right?
Break even was just where you couldn't, like, where you weren't making money, so I thought it was like the lowest you could sell, like just making no money at all.
No, break even is when you finally made back everything. It's like you basically made back everything that you invested.
You have to make
So-
3,000, at least 3,000.
So what was this first value here?
68.5.
0.5 what?
68.5 units sold.
All right, so about 68.5. So basically, we can't sell 68 units. We can't sell half of a unit. So at 69 units, that's when this guy's gonna actually start making some money, or this girl's gonna start making some money. Okay? And after a certain number of amounts, whatever that value was, then they're gonna start losing money. Okay? Or they're gonna just start over because it's a new week. So
So they can lose money when they sell it?
it depends. Or usually after that certain point in time, then the week's gonna start over, and then you're gonna be back to where you are.
So from here you can find how much each unit is.
No, this is asking for the number of units to break even. So not how much each unit was worth, but how many you would have to actually make
But you can find out how much unit is worth
using this equation, right?
if you equal to 69.
This last one, it says a farmer has 170 meters of fencing to fence off a rectangular area. Find the length and width that gives the maximum area, as well as talking about with the last problem. So first off, using that very first problem, we already know that area equals length times width. We're going to need another equation to get area in terms of one variable. What equation is that? It's the perimeter one. So this time, it's going to be 2W plus 2L because I don't have anything blocking off my rectangular area. What is going to be the P? 170. What variable do you want to solve for? L? Okay. Doesn't matter. So I'm going to subtract 2W, and then I'm going to divide everything by 2. What's 170 divided by 2? So I'm going to have 85 minus W equals L. So my area equation is 85W minus W squared. Now it's asking us to find the length and width that gives the maximum area. So what am I looking for here? I am looking for W, but which W? I'm not looking for a W that's going to give me an x-intercept. I'm looking for the W that's going to give me the maximum. So this is where I was talking about, where you would use the vertex, but this time you're just looking for the x-coordinate of the vertex, because that's going to represent W. The x-coordinate of the vertex tells you basically what width is going to actually give you your maximum area. So negative B over 2A, what is that? 42.5. So your width has to be 42.5 meters. How do you find your length? Plug it in where? So this one right here. So 85 minus 42.5 equals 42.5. If you did not know, yes, your maximum area of any rectangle is always going to be a square. Every time. Now part B, it says the farmer has 110 meters of fencing to fence off a rectangular area. Part of one side is a wall of length 15 meters. So we got a completely different piece of rectangular land. This time we only have 110 meters of fencing. And on top of that, we have a wall that's on part of one of our sides that's 15 meters long.
So we just do it.
We get rid of 15 meters on the what? On the width. So in our perimeter equation, we still have two lengths. We have one full W, but it's going to be plus W minus 15 to represent the other width. Does everybody see that?
So 2 W's.
I have 110 meters of fencing. And I'm trying to find the dimensions of the field that give the maximum area. Dimensions means what? Dimensions? X and Y. I don't have X and Y in this problem, so they're going to represent what? Length and width. Okay? Dimensions are lengths and widths. So, area. Yet again. What variable do you want to solve for here? L? Okay? Doesn't matter. Really?
He said
Okay, I didn't hear. But it doesn't matter. If you want to solve for W, by all means, knock stuff out. Okay? Add 15 over. What's 110 plus 15?
125.
125 equals 2L plus 2W. If I'm solving for L, I need to subtract over, again, the 2W, and then,
plus.
and then
Divide by 2.
divide by 2. What's 125 divided by 2?
62.5.
Minus W. That is your length. So my equation for my area should have been 62.5 W minus W squared. And if I'm looking for the dimensions that give my maximum area, what am I looking for?
The y coordinate is the vertex.
Not the y coordinate of the vertex.
Yeah.
I'm looking for the x because the x gives me one of my dimensions. The y actually gives me the maximum area, but I'm not concerned about my other dimensions. So negative b over 2a is what? Because a was a negative 31.25. That is the dimensions for the width, meters. And then you find the length by plugging in. So what's the length? Which is? Which is?